Today we're going to continue talking about points, lines, and planes, but we're going to add to that. So you're not going to have to write very much today. In fact, as you may not have to write at all. I may have filled out everything. I usually don't do that because I want you to be, doing something. After a while, you start to drift off if you're just listening to someone. So the next thing we're going to talk about is called a segment. So a segment is a part of a line, which means, what is the one primary characteristic about a line? Anybody? One word. Straight. It's straight, okay? So because it's part of a line, it has to be straight. It's formed by 2 points. Those 2 points are called the end points, and all the points between them. Here's an example. I've got 2 points, A and B, and all of the points between them. When we say between, we automatically mean that they are all on the same line. Don't draw this, but if I have a point right here, I'll call that C. C is not between A and B. The points between A and B are all on the same line. Let me get rid of that. So segments are straight and they are finite. Remember, we talked a little bit about this yesterday. Finite means it doesn't go on forever. Finite is limited. It's a subset of a line. It's not the same as a ray. I don't believe we talked about rays yet, but a ray looks like this. So you add that if you would, please. This is what a ray looks like. A ray is also part of a line. Oh, sorry. If ever something is in a place where you can't see it well, just let me know. The way that we do the symbol for this, for a line, we put arrows on the ends. For a segment, we just don't put the arrows. Now, some older textbooks put big old dots on the end. You don't need to do that. If you want to, you're welcome to. But it's not necessary. So this segment up here, we could call it segment AB, or we could call it segment BA. It doesn't matter which order we say them in. We're just saying it's all the points between A and B, which means they're all on that one piece of a line. All right, let's go on to page 2. So speaking of rays, a ray is the part of a line formed by a point called the end point. I really wish they called it the starting point, because it is kind of, if you think about the motion, where it starts. And all of the collinear points. What's collinear mean? On the same line to one side of that point. So this ray, we would name it ray RS. You cannot name this ray SR. The first letter has to be the end point. And then the second letter has to be a point that tells you where to go. This says start at R, go through S, and then keep going that direction forever. That's why there's an arrow on the end of it. Same thing here. We're talking about this ray. Even though this ray goes to the left, our symbol always goes to the right. All right, one of you smart people, tell me, why do you think the symbol always goes to the right? I'm sorry? But why? Yeah, it's because we read from left to right. Okay? Since we read from left to right, that's why that symbol goes left to right. So this says start at K, go through J, and then keep going. So start at K, go through J, and keep going infinitely in that direction. Okay? The other thing is just as a practical matter, it would be really hard to try and match. What if you had an array, you don't need to draw this, that did like this? What are you going to do? Start making your symbols go like that? That starts to get ridiculous, doesn't it? Okay? So that's why. And rays are straight and infinite, but only in one direction. They're infinite, but they don't go in both directions. What is it that goes in both directions? Everybody, what is it?
A line.
A line goes in both directions. Now, we talked a little bit about planes yesterday, but not very much. So let's fill in the details of that. A plane is a flat surface with no thickness, extending infinitely in all directions. So, the top of your desk is like a plane in that it's mostly flat. I know it's not perfectly flat, but it's mostly flat. And if we could make it really, really, really thin and make it extend infinitely in all directions, it would be more like a plane. Okay? In this room, what things are like a plane? I'll take volunteers. Yes?
Geometry posters right there.
All right, that poster is like a plane. It is flat-ish, and it extends. Yes?
The whiteboards.
Okay, the whiteboards are like planes. Yes, sir? The floor, I always use the floor as one of the planes because it's one of the easiest ones to see, right? So it's a great big thing. Now, I'll tell you, this floor is not very flat. We had a leak back on one of those windows a little over a year ago, and the water all ran down here. There was a big puddle up here at the front. Okay? But the floor is basically like a plane. So if the floor is basically like a plane, what else is like a plane? The ceiling's like a plane also. Okay? The walls are like planes. Anything that is flat is like a plane. That's the primary characteristic. So for a line, the primary characteristic is that it's straight. With a plane, the primary characteristic is that it is flat. The way that we draw it is like this. When you draw a plane, you draw a parallelogram. We usually draw it leaning to one side. When you're naming the plane, there are actually many different ways you can name a plane. One way is sometimes they'll have a capital script or italicized or cursive letter in one of the corners. That's the name of the plane. You can also name a plane by any three non-collinear points on the plane. So for example, A, B, and D, you can name the plane that. I could also name it plane, how about A, B, and C? Is that okay? Can I name that plane ABC? Yeah, because A, B, and C are non-collinear points. Now, I'm going to add one point, if you'll add a point to this also. Directly in between A and C, please add E. And let's draw a line through it to show that the line goes through all three of those points. And you can do what I do. If you miss one of the points, just make your dot bigger. So I cannot name it plane AEC. because those points are collinear. Now, you're like, that feels like a random rule. Who made that up? Why is that a rule? Well, let me show you real quick. So on this piece of paper, I'm going to draw a line. That has those 3 points A, E, and C all on a line. So everybody see that? Okay. This green plane that I'm holding, does it go through A, E, and C also? I'm trying to get to go through all of them. Does it go through all of those? Yes. If I say A, E, and C, or plane AEC, do you know if I'm talking about the red plane or talking about the green plane? Don't know. But if I add point B up here, if I say plane ABC, can I make this green plane go through A and B and C all the time without it being right just flat on top of this one? No. That's why it needs to be 3 non-collinear points to name the plane. All right, let's move on to page 3. This is going really quickly. So if a line intersects a plane, the intersection is a single point. I will expect you to be able to do a diagram like this. This is probably about as complicated as it gets for ones that I would expect you to do. So in this diagram, what's happening is this. You've got plane P. That's this red piece of paper. Okay? Line AB is sticking out of the paper, something like that. Okay? Now, from where you're sitting, can you see all of the pencil? Some people aren't even looking, so I know you can't see all of the pencil. All right? Can you see all the pencil? No. The part that you can't see because the plane is in the way is the part that's dotted right here. Right? Do you see at some point where it kind of looks like can you see the bottom of the pencil now, everybody? Not quite? Sorry. All right. Do you see how it kind of, all of a sudden the pencil reappears? That's this part down here where you can see it again. So this is called a hidden line. It's behind something, or there's something between you and it. So this line is going up and down through plane P. These other lines are on plane P. So here, line AB intersects plane P. So line AB is this line going up and down. Here's plane P. And it also intersects line XZ at X. When we say it intersects, it's what they have in common. What's part of both of them? So if I say, what's the intersection of line AB and plane P, what's the only point that's on both of them? X is the only point that is part of this line and is part of the plane, because this line is not lying down on the plane, it's going up and then going down through the plane. One thing to notice here, line AB does not intersect line WY. WY is on the plane. Let me show you what this is going to look like. Let's see, X is up there. I'm going to turn around this way. right, so here's what this looks like. So here's plane P. XZ and WY are on the plane and they intersect at Q, right? Line AB, which is my pencil, goes through the plane. Does it ever touch line WY? No. It's never going to run into that. That's what this is trying to illustrate. Okay? One of the things you have to get used to, and fortunately we don't get to 3 dimensions a lot until later on, but one of the things you have to get used to is how to illustrate 3D things in 2 dimensions. And one of the ways is with hidden lines like that. So if you're asked to explain why, you can say because WY is on plane P, and where AB intersects plane P is not on WY. Where line AB intersects plane P is on line XZ, not on line WY. And we already talked about this. Line XZ and line WY lie in plane P and intersect each other at Q. So they intersect here at point Q. All right. Last thing, if 2 planes intersect, their intersection is a line. So we're just going to do a little bit of shading on this. Plane M, this is like a box, right? So if you can imagine, a cardboard box or something. Plane M is the top. We'll just shade that in. And I'll use a different color. Oh, let's use this. Plane R is over here. Where they meet is here. And that's actually going to keep going in both directions because the planes keep going. So planes M and R intersect at line AB. In the room, where can you see that? Look right over here. I think everyone can see this one. This wall is like a plane, right? This wall is like a plane. Where they meet is this nice straight line. So when 2 planes intersect, then their intersection is a line like this. Okay? Any questions about that? All right. What I'd like you to do is go ahead and get out your computers. I don't know how well the internet is working currently, but we'll give it a try. Look up the assignment and then open your textbook. Again, this is part of why I recommend that you go ahead and download all those PDFs for your textbook because sometimes the internet is not reliable. Tell you what, to help you out, I'll write the assignment up on the board. I don't always do that, but that way you don't have to get into RenWeb, which is running incredibly slowly today.